So I'm here with Robin White from Material Research Department at LIST. I'm here in this mega booth, Robin, named hydrogen. What is it about?
It's a really big topic, a really important topic. A key aspect of the ongoing energy transition as we transit to a more sustainable and renewable energy-based economy. And we've got some examples here in our mega booth today which demonstrate some of our activities in that direction. So the first activity relates to harnessing the kinetic energy of waves through an energy harvesting device, which then provides an electrical current to an electrolyzer, a device which then can electrochemically split water into hydrogen and oxygen. And we can do this in seawater, for example, and we can use solar energy to purify the water, which then is fed to the electrolyzer. And this can be deployed, for example, in marine environments.
That's really fascinating. I see you have something over there. What is it about?
So this looks towards a much higher level of materials integration, yeah? So we can utilize solar energy directly to produce our hydrogen. So we've got photoactive, electroactive components in a so-called photoelectrochemical cell, which can then use photonic energy to directly split water into hydrogen. So a completely integrated device, which goes beyond what we have, shall we say, in the marketplace at the moment, which is normally separate solar, photovoltaic and electrolyzer devices.
Now, Robin just showed us how do they produce hydrogen with natural elements. We just saw with the waves, and now we see with the sun. And how do you store that?
Yeah, so hydrogen is a gas, and inherently we need to compress that and store that over long periods of time. And depending on the application, for example, mobility, we want to do that in as light a way as possible so we can improve the gravimetric energy density. And that's one aspect we're working on, is the hydrogen storage tanks. For example, in a mobility context, we can use lightweight materials, for example, based on carbon fibers and epoxy resins, for example, in this demonstration. And we can look at that from improving the sustainability credentials of the material. We use specific chemistry, bio-based chemistry, for example, to improve the life cycle. We can look to improve the recyclability at the end of life. We can also think about safety elements. So we can integrate, for example, sensors directly into the tanks. We can print them directly onto the tanks themselves. These are strain gauge detectors. So we can monitor, for example, the behavior of the materials themselves whilst they're in application.
Okay, that's very fascinating. And for example, I could put that in my car, for example.
Yeah, so for example, you could put that into a car, you could put it into aviation, you could put it into marine, all kinds of mobility options. And this, as I said, hydrogen plays a multifaceted role in this energy transition. It's a very important technology, mobility being one aspect, but coupling energy, renewable energy, and mobility and industry is a critical thing to do if we want to reduce the emissions going forward in terms of the energy transition.
Thank you very much, Robin. And this is how LIST works in this hot topic. Thank you.